Hello everyone and welcome back to Pre-Algebra with Miss Betsy. Today we're going to be learning all about exponential notation. This is the book that we're using. It's Pre-Algebra for Christian Schools, published by Bob Jones University Press. It's the first edition. Second edition, the tracking and sequencing of material is different and your section numbers are not going to line up. You can still gain value from this video, however, by searching just on the title and studying about exponential notation. So, before we go ahead and get started, let's pray. Let's see what my ultra lame joke is for the day and see what this section holds for us. Father, I love you. I thank you that I am sure that you love me and that you are active and involved in my life. Father, I thank you that you have given to us an ability to study and to learn and to understand. And I ask that you would help us to apply ourselves to the task at hand so that we can unravel some of the difficulties of working with new subject material and move on and make good progress in our course today. Thank you that you love us, and I pray in the name of your Son, Jesus. Amen. Okay. Math question. What is it? It has 12 legs, it has 6 eyes, 3 tails, and it can't see. 12 legs, 6 eyes, 3 tails, and it can't see. Well, you remember the story about the 3 blind mice? They are the ones who have all of those things. Exponential notation. Okay, we're going to have some more vocabulary yet again and a little bit of a new concept. And we're going to see that exponential notation is somewhat similar to multiplication. But first, this is section 5.4. It's on page 153 in your text. When you first started learning how to do arithmetic, you added numbers together. And then you eventually got to where you could say, instead, you could say 2 plus 2 was equal to 4. And that was a really important fact for you to learn, and looking now, it's like, well, duh, of course 2 plus 2 is equal to 4. Everybody knows that. But you didn't know that when you first began to learn how to add. And then you would add more 2's, and you would say 2 plus 2 plus 2 was equal to 6. Or maybe you had 2 plus 2 plus 2 plus 2 plus 2, and your plus sign, and you had to go take a little while to figure out that that was equal to 10. And then it quickly began to be a problem, and you learned something that was called multiplication. What if you had this addition problem, 2 plus 2 plus 2 plus 2 plus 2 plus 2? And we wanted to solve that like we do in algebra, just one step at a time. 4 plus 2 plus 2 plus 2 plus 2. 6 plus 2 plus 2 plus 2. And I'm feeling like there should be a button. Whoops. There should be a button that I can push to say the plus 2. And see, I'm going so fast, I'm not even sure I got this correct. Well, that took quite a few steps to sequentially add 2, and then add 2 again, and 2 again, and 2 again, and we learned that a really fast way of saying 2 added together was 6 times 2 was equal to 12. And that was a much nicer math fact to have than to have to add 2's together one after another, after another, after another, after another, until you finally end up with 12. And when you first began working on your multiplication tables, it was a little bit of a challenge for you to remember that 6 times 2 is 12, but now it's second nature to you. Well, just like multiplication relates to addition, it's sort of like a fast addition. What we're talking about today, which is exponential notation, is sort of like fast multiplication. And it's a shorthand way of writing it. And let's say that we have 2 times 2. Everybody knows that 2 times 2 is 4. 2 times 2 times 2 is 8. 2 times 2 is 4 times 2 is 8 times 2 is 16. But what if you had, just like we had all of those addition problems, and you went ahead and figured this out one step at a time. 2 times 2 is 4 times 2 times 2 times 2 times 2 times 2. 4 times 2 is 8 times 2, 16 times 2 times 2 times 2, 32 times 2 times 2, 64 times 2, 128. Now let me see if I did this right. 1, 2, 3, 4, 5, 6, 7. Sure took a long time to come up with 128. You get tired of writing your numbers, and if you're not careful, you're going to actually lose track and make a mistake in here. This is multiplication, and what do you notice here? We're using the same factor over and over and over again. Factors are those numbers, remember, that you multiply together. How many times here did we use 2 as a factor? We used it twice. In exponential notation, we show it like that. How many times did we use 2 here as a factor? We used it 3 times. How many times did we use it here? 1, 2, 3, 4. We used 2 as a factor 4 times. What about this problem down here that we started off with? How many times did we use 2 as a factor? We used it 7 times. Now, this strange way of writing numbers here is what we call exponential notation. Some of you are familiar with this, some of you are not. Exponential notation. This is a piece of vocabulary, or a vocabulary word, you have to know. You have to know exponential notation looks like this. And if you look here, you say, there's a real pattern going on. I have the 2 sort of sitting down here at the bottom, and I've got this other number floating up here in space a little bit. Well, what is the 2 sitting down at the bottom? That's the factor, isn't it? 2 is used as a factor in every one of these problems here. And do you notice a connection with the number that's sort of floating up there in space? Well, 2 is used as a factor twice. 2 is used as a factor 3 times. 1, 2, 3, 4 times the 2 is used as a factor. 1, 2, 3, 4, 5, 6, 7 times the 2 is used as a factor. And that's exactly what we have going on with exponential notation. You have the number that sort of sits on the line. Well, I guess I left that marker off pretty far. And you have the number that's up to the right of it. This bottom number here, this is called the base. Have to know that. This number right here, that's up at the top, this is called an exponent. And this is where we get the term exponential notation. So this is an exponential form. You have the base, which is 2, and the exponent. And this, I guess I'll try and write it out, in exponential notation, the base is used as a factor factor as many times as the exponent. Now that's not phrased in a manner that that makes me really pleased with what I've said, but here's our base, here's our exponent. This exponential notation, if we want to make this work out, we're going to take the base and we're going to use it as a factor as many times as that exponent is. 2 with a little 3 says use 2 as a factor 3 times. This is read 2 to the third or 2 to the third power. They call this a power of 2. And I really want you to make sure that you read your textbook material because they have a lot of time that they spend talking about terminology. But in exponential notation, the base is used as a factor as many times as the exponent is. So if they ask you to simplify 2 to the 2 cubed or 2 to the third power, you're going to have to realize that that means 2 times 2 times 2, and that when you simplify that, you're going to end up with 8. So 2 cubed, or 2 to the third power, is equal to 8. And your book goes through telling you illustrating for you how to read those numbers, how to read those exponents. So if we have 5 squared, the 2 can be read 5 squared most commonly. The base, what's the base? The base is 5. What's the exponent? The exponent is 2, so that means use the base as a factor 2 times. And 5 times 5 is equal to 25. What if you have 3 to the 4th? This says use 3 as a factor 4 times. And then you go through and figure out that multiplication. 3 times 3 is 9, times 3 times 3. 27 times 3 is 81. So 3 to the 4th is 81. And let me step through these to show you how we're going to read these, how we're going to pronounce these powers. When you use the factor, when you use the base as a factor twice, we use the term squared. 2 squared, 5 squared, 7 squared, just means that you're using it as a factor twice. And I think it comes from the area of a square. The area of a square, they'll tell us that that is the side, because the area of a square has sides that are the same. And to find the area of a square, it's you multiply the side times the side, or you can say that that's the sides squared. And it comes from this square unit here. And I think that's where we get the 2 squared. What if you have a third dimension here? You have a cube of sugar. 2 cubed, length, width, height. 2 squared, 2 cubed, and then they say 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 21st. And it's okay to say 2 to the 4th power. Alright? So let's see what else we need to talk about with laying the foundation here for this exponential notation. See, when you write a number with a base and an exponent, we say, like I said, the number is in exponential form. Here's an example of a problem, and it says, write 6 times 6 times 6, and you notice they're using that x there for multiplication. They're going to do that. I'm not going to do it. It's not wrong for you to do that, but be moving away from it. Remember, use the dot or use the parentheses. It says write 6 times 6 times 6 in exponential form. So what you're looking for is you're looking for a factor that shows up repeated number of times. And what is that factor? that factor is a 6. So that is going to be the base. How many times is it used as a factor? It's used as a factor 3 times. Write in exponential notation was your instructions. Exponential notation. That's what you were told to do. And you see here that we have 6. It's used as a factor 3 times. This is what we call exponential notation. The 6 is the base, and the 3 is the exponent. All right? Let's move on to the next page, 154. And they show you the pattern, which I just finished going through a pattern to see the relationship between the exponent and the base and how many times you use the factors. Now, there's something that I want to show you. I only showed you 2 to the second, or 2 squared, 2 cubed, 2 to the fourth. We also have 2 to the first. Using our exponential rules, that's just the base used as a factor 1 time. So 2 to the first is the same as 2. So we typically are not going to indicate an exponent of 1. We understand that that has an exponent of 1, but we're not going to show it. And then we can have 2 to the 0. And we have a definition here. And it says in the middle of the page, for every number n to the first is n. For every number n, where n is not equal to 0, n to the 0 is equal to 1. Okay, that sounds like a foreign language. All they're telling you is any number here if that's to the first power, it's just going to be the number. For example, if you have 8 to the first, that's going to be 8. If you have a -2 to the first, that's going to be a -2, and I should not have done that. I don't want to do the negative numbers. If you're going to have 16 to the first, you have a 16. If you have 2012 to the first, that just equals the number. Regardless of what the number is, if it's raised to the first power, there's no change. This 1 right here is unnecessary. And then they show you in algebra, they say for any number n, where n is not equal to 0, n to the 0 is equal to 1. And this is something that you like, because this says no matter what your base is equal to, if your exponent is 0, it always equals 1. 2 to the 0 is 1. 175 to the 0 is 1. 83 to the 0 power is 1. Anything raised to the 0 power, anything that has an exponent there of 0, has a value of 1. And you simply have to understand that. You have to understand that in exponential notation, for example, if we are using 3, to the 0 power, 3 to the 0 is going to be 1. 3 to the first is always going to be, anything to the first is always going to be the number itself. And then, as you move up, that's when things change. You have 3 times 3. If I can write a 3, 3 times 3, which is 9. Here you have 3 used as a factor 3 times. The base says use it as a factor. The exponent says use it as a factor that many times. You have 27. You have 3 to the 4th, which says use 3 as a factor 4 times. to give you a result of 81. Again, anything to the 0 power is 1. Anything raised to the first power is just the same as the number itself. Now, example 2 says, write these problems as a product of repeated factors, simplify if possible. One of those was 3 to the 4th. 3 to the 4th we just finished doing. This is our shorthand multiplication. This 3 to the 4th, which is what we call exponential notation, means that we're going to use 3 as a factor 4 separate times. And then, to simply say 3 times 3 times 3 times 3, that's not sufficient. You need to multiply that out so that it is simplified. So the simplified form of 3 to the 4th power is 81. And then the next problem that they showed you was 7 to the 0 power. Has nothing to do with the 7. What your mind and your eye keys in on is that we have an exponent that's 0. The exponent of 0 evaluates always to 1. So 7 to the 0 power simplifies to 1. Let me move on to this next page. And now, this is something that we're just going to dip our feet in the water right here, stick our toe in the water. This is what you do. It says to multiply powers with like bases, you can simply add the exponents. So, at this point, if you don't already understand what we're talking about, I want you to follow the pattern. I'm going to show you why the pattern works. Now there's a key piece of information here that you might fall over, might trip over. Top of page 155, it says to multiply powers with like bases. Like bases means it has to be the same base. Let's say that we have 2 cubed times 2 squared. What they say is that you can simply add the exponents. So, what do we get when we add the exponents here? We keep the base and we add the exponents, which ends up with our result of 2 to the 5th using exponents, right? Because they said if you're multiplying powers that have the same bases, so you've got exponential expressions here, the base is the same, which is a 2. What you do is you keep the base and you add the exponents. And you ended up with 2 to the 5th, which is 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. You have to take it because you don't have variables there. After you've gotten your exponential notation, go ahead and multiply that out. Well, that seems awful weird to be adding numbers together when we're multiplying. So let me show you what we have. What does 2 cubed mean? It means take 2 and use it as a factor 3 times, doesn't it? 2 cubed, the base is a 2, use it as a factor 3 times. So this is another way of writing 2 cubed. It's expanded out. Times, what's 2 squared mean? It means take 2, the base, use it as a factor 2 times. Now we have parentheses here. Do we need to have them there? No, that was just where we were indicating that 2 cubed was 2 used as a factor 3 times. 2 squared was 2 used as a factor twice. What do we have? We have 2 used as a factor 1, 2, 3, 4, 5 times. 2 to the 5th, which is 32. And that's why it is that when you're going to multiply exponentials, you add the exponents. That's because these exponents here are indicating repeated multiplication. So this is your exponent rule, and you need to, for adding exponents, you need to begin to become accustomed to this. X to the A times x to the b is equal to x to the a plus b. And the first part of this definition, where we're multiplying powers with like bases, it says for whole numbers x, I don't think they want to do that for x. For any number x, let me rewrite this. For any number x, and for whole numbers a and b. What are they talking about here? They're saying that x can be any number in the world you want it to be. And they're saying that your exponent has to be a whole number. What are whole numbers? They're the numbers that follow this pattern. 0, 1, 2, 3, 4, and 5. That's what we're talking about now. And they say that if you have the same base, you simply add the exponents. So 3 to the 6th times 3 squared, you would keep the base, and you would add the exponents. 6 plus 2 would give you 3 to the 8th. If you have 2 squared times 2 cubed times 2 to the 4th, you have the same base, so you're going to keep that, and you're going to add the exponents. 5 is equal to 2 to the 9th. It's simply a pattern that they want you to recognize. All right? Let me go ahead and do some of these skill check for you. And I hope that this is being, hope I'm spending way more time on this than you actually need. This says identify the base and the exponent. If you have a to the 5th, what's the base? The a is the base. The exponent is the 5. You say, oh, but it's not a number. Doesn't matter. Exponential notation means use the base as a factor that many times. A is the base, 5 is the exponent. That means that a is used as a factor 5 times. Now, they say, write as a product of repeated factors and simplify if possible. We have 7 to the 4th. What does 7 to the 4th mean? It means use 7 as a factor 4 times. Is that enough of an answer? No, they want you to actually go through and do your multiplication, which I'm not going to do, but I'm going to tell you that the answer here would be 2,401. And there's actually a key for exponentials on your calculator, but I'm not going to address that right now. Now, however, they have b to the 6th. b to the 6th. How do we write that out as a product of repeated factors? Well, b times b times b times b times b times b, I think. There. You see that exponential notation is clearly nicer to write than to write 6b is connected with multiplication signs. The second part of the instruction said simplify if possible. Here, we could simplify to 7 to the 4th, but you cannot simplify b to the 6th because that's a variable. Then they ask you to write in exponential notation. And we've been doing this. Here's one. How do you convert this into exponential notation? First, you notice that you have the same number being used as a factor. That becomes your base. How many times is it used as a factor? It's used 4 times. So, 5 to the 4th is exponential notation that indicates this value right here, which is actually 625. And then we have this problem here, and pay attention to this. It says multiply, write the answers in exponential form. This is problem 10 in your skill check. Make sure that you're reading your instructions and doing what they say. 10 to the 4th, 10 to the 7th, 10 squared. 10 to the 4th times 10 to the 7th times 10 squared. The skill check says multiply, show your answers in exponential form. Exponential form here, we have the same base being used in these factors here. So we have 10, we add the exponents. 10 to the 4 plus 7 plus 2, 10 to the 13th. That's your answer. Because it says write your answers in exponential form. They don't expect you to say 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1,000,000. It wouldn't be a meaningful number. That's a benefit of using scientific notation. This 10 to the 13 right here is a very, very large number. Numbers of this size get used in science all of the time. But that's the end of section 5.4. If you have difficulties, send me a text or bring your questions to class on Friday, and I will see you then.